you would make sure that you're at standard W1. This standard, you've done Algebra 1, you spent a whole chapter on it in Algebra 1, so it'll probably look familiar. But just to make sure that we're all on the same playing field, we're covering it again in Algebra 2. Plus, we use this quite often in other units. Alright, another important part of algebra. So, we've talked about the graphing part. That was the previous section. Another important part is being able to take data and do something with it. Make predictions, make graphs, basically put it into a format that you can then utilize to find future values. To practice this, we write equations for all the different types of functions, or you could also write patterns we come across in this class. When you start to analyze data and figure out what function best represents it, you have to know each function's characteristics well enough to decide based on the data patterns what the model will be. So we'll look at lots of different functions which represent different patterns, and those patterns have characteristics, otherwise you wouldn't be able to recognize them. A linear function characteristic, or some of them, is that the rate of change is constant, meaning the data grows or decreases at a steady rate. Okay, there's no fluctuation. It doesn't jump up and then all of a sudden go down. It's pretty steady, either increasing or decreasing. Another characteristic is that the data forms a line. Now sometimes not all the points lie directly on the line, as you'll see in our bone length packet, but at least when you plot the data, it kind of looks like it's a linear, we call a linear trend, that it might form a line. Another characteristic is that it crosses the y-axis. What that means is that you have a starting point for your data. So at time equals 0, you do have some sort of y value. To write the equation of a linear function, you must have at least two pieces of information. You must have the value of the slope, or how steep the line is, and a point. So you need a data point, or an xy, that the line or pattern is said to pass through. Sometimes this information is given to you. Sometimes you have to do a little work to find it. The two forms that we are going to use the most to make linear patterns or to make linear equations is the slope-intercept form, which everybody's pretty familiar with, y equals mx plus b. xy is a point on the line. It represents any point on the line. M is the slope, and b is the y-intercept. Okay. And then the other form that we use is the point-slope form. And that form is y minus y1 equals m times x minus x1. The plane xy, so this x and this y, if you pair those together, that is any point on the line. That x and that y always stay when we write an equation. The x1, y1 is a particular point. So this is a point that's usually given to you. It says the line goes through the point 32 or something like that. And m is the slope still. Okay. So normally for these problems, and I think we have, well, 3 at least. Normally for these problems, we have to look at the data that's given to us, and then based on that, either use the slope-intercept form or point-slope. Now, the name of these forms actually give away what data you would need. For the slope-intercept, they'd have to give you the slope and the y-intercept. To use the point-slope form, they have to give you a point on line and the slope. So we have, let's see for this one, we're going to write an equation of a line given the slope of 2/3 and it passes through the y-axis at the point 0, 4. Okay, so the two pieces of information it gives you is the slope of 2/3 and that it passes through the point, or passes through the y-axis at the point 0, 4. They give you the slope, they give you the y-intercept. So because they give you the slope and the y-intercept, you're going to use y equals mx plus b. So I'm going to write down the general form. Remember the x and the y always stay when you write the equation because the x and y represent any point on the line. Not a particular point, but just any point. Because remember from geometry that a line is made up of millions and millions and millions of points. So we need to keep the x and the y there. So we're going to replace the m with what my slope is, 2/3. And we're going to place the b with what my y-intercept is, which it gives you two values here. You're not going to write 0, 4. What this means is that when x is 0, so look in this graph, when x is 0, y is 4. So we just need that value of 4. And you're done. Okay? So if they give you the slope and they give you the y-intercept, then just use the slope-intercept form. And it's pretty straightforward. Okay, if we go to example 2, we're going to write the equation of a line that passes through, we'll go 2/3, or sorry, not 2/3, 2, 3, and -5, 4. Okay. Remember on the previous page I said in order to write the equation of a linear function you have to have the slope and a point. Well, we are given 2 points here. To find the slope, we can find the slope from 2 points. We just have to do an extra step. So I need the slope and a point. I have 2 points. I need the slope. I'm going to stack and subtract my two values here. And all I'm trying to do in this step is to find my rise over run, or my slope. So I'm going to subtract my y values because that gives me my rise. 3 minus 4 gives me -1. And then 2 minus the -5. When you subtract the negative, really adding it there. So that ends up being 7. So -1/7 is my slope. Now, because I'm given a point and a slope, I'm not given the y-intercept anywhere. I have to use the point-slope form from the previous page. So I'm going to write down the general form, and then I'm going to plug in and simplify what I need to. I have the slope, but I have 2 points to choose from. My rule of thumb is to choose what looks like the easier point. So I'm going to pick 2, 3 because those numbers are a little bit smaller. This ends up being your x1 and your y1, or that particular point you're going to plug in. Remember that this x and this y stay put. Okay, so my particular y value of my point is 3. My slope is -1/7. This x stays put, and my particular x value of my point is 2. Now at this juncture, once you have it set up, the rest of it's just simplifying. We're going to get y by itself. So I'm going to distribute -1/7 through. Now when you're multiplying two fractions, because technically this is 2 over 1, you multiply across the top and the bottom. So -1 times -2 is +2. 7 times 1 is 7. And I'm going to add 3 to both sides. When you add 3, you need common denominators. So I'm going to have to multiply this by 7 over 7. And I would get 2/7 plus 21 over 7. I now have common denominators, so I can add across on the top. So my final y-intercept here would be 22 over 7. Okay. As review again, when you're given 2 points on a line, you can write the equation still. You just need to stack and subtract to find your slope. Then pick one of your points, because then you can do the point-slope form. Plug them in and simplify. Okay. And then let's do example 3. This one is a 4-type problem. I will probably save that for doing it either in class or in the next homework video. So if you're looking for this one to, if you're re-watching this later, look for this example either in a separate video that I've attached or in the next video over the next unit, or sorry, next standard. Anyway, all right, the other way that you'll see this is writing the equation of a linear function with a perpendicular line. So the information that I'm going to give you is a little bit different. You're going to write the equation of a line that passes through, let's go to the point 3, -6, and is perpendicular to y equals 2/3 x plus 1. Okay. Remember what we need to write the equation of a line. We need the slope and a point. We're given a point that my line passes through. However, I'm not given a slope. Well, I am given a slope, but in a roundabout way. We have to remember how perpendicular lines are related. Perpendicular lines are completely opposite, which means everything about them is opposite, including their slopes. So the slope of this line, which my line is perpendicular to, that slope is 2/3. My slope isn't 2/3. My slope is completely opposite of 2/3. So I'm going to use the fact that I know my slope is completely opposite of 2/3. Completely opposite would mean you're going to flip it and make it negative. So my slope is actually -3/2. Okay, might be good to write that down. Perpendicular lines have opposite slopes. Keep in mind, we don't even care about that y-intercept. That does nothing for me. I'm just using this line to find my slope because I know my line is perpendicular to this one. Okay, so I write down the perpendicular slope of -3/2, and then I'm going to use the point 3, -6 as my x1, y1. And then it's setting it up again into the point slope form. So we have y minus y1, which ends up being y plus 6 when I plug in the -6 there. -3/2 is my slope. And then my x1 is 3. And then I'm going to distribute again, because now I'm simplifying. -3/2 times -3 would be 9/2. And then I'm going to subtract 6 from both sides. So 9/2 minus 6 over 1, really that'd be 12 over 2 if I had common denominators. So 9 minus 12 gives me -3. So you have -3/2 x minus 3/2. Okay. You're going to get a lot of practice on this stuff, especially like these type and these type up here. Because it's been a while probably since Algebra 1. And again, remember example 4, we're not going to cover it today, but we will cover it, and there will be a video in case you want to ever look at it again, but this is a 4-type problem. So all these problems above it are 3-type problems.